Welcome back. Today, we're going to continue in Chapter 3 with a review of polynomial division. Now, polynomial division is basically just long division that looks a little bit fancier. So in order to do this, we're going to take a review of long division. Let's say, for example, that I wanted to divide 15 into 47/28. What you need to do here is you need to see how many times the number goes into each piece. 15 goes into 4 0 times, so we'll skip that. 15 goes into 47 3 times. So we'll multiply 15 times 3 and subtract, and then bring down. We'll do the same thing again. 15 goes into 22 1 time. Minus 15 leaves us with 7. And then we get one more, goes into 78 5 times. And here we end up having a remainder. So we'll say 315 remainder of 3. Or we could say 315 and 3/15. Hey, that's a coincidence. Regardless of which way we do it, with a remainder or a quotient at the end, the process is the same. You see how far the thing you're dividing by goes into each piece. You mark that down, and then you subtract, multiply, and repeat the process until you're done. You then get to a remainder. We can do the same thing with polynomials. So let's divide x minus 2 into x cubed plus 4x squared minus 5x minus 14. So we'll put x minus 2 into here. If I want x to go into x cubed, I would need to multiply by x squared. We're going to put it here because I need to multiply this entire piece, which means I'll need to line up both pieces here. So if I multiply this by x squared, what I'll get here is x cubed minus 2x squared. Then we need to subtract this. So since I'm subtracting, I'll distribute this negative into the parentheses that are here to subtract the entire thing, which means that I'll have a negative here and cross over to make a plus here. Thus, I get 6x squared. Then I'll bring down the negative 5x. Just like regular long division, you divide, you multiply, you subtract, you check, and you bring down. It's does McDonald's sell cheeseburgers all over again. Let's repeat the process. X minus 2 goes into 6x squared 6x times. So that means I'll have 6x squared minus 12x. Once again, I need to subtract, so I'll cross over as I distribute. And that gives me 7x minus 14. We'll repeat one more time. 7x, I'll need to multiply by 7. And in this case, I got a remainder of 0. X squared plus 6x plus 7. If I wanted to double check that my work was correct, I could multiply it out. X minus 2 multiplied by x squared plus 6x plus 7. So that means I'll have x cubed plus 6x squared plus 7x minus 2x squared minus 12x minus 14. And then combining like terms, x cubed plus 4x minus 4x squared minus 5x minus 14. And it matches. So we've done everything correctly. Now, you may recall another way of doing this using synthetic division. And the idea of synthetic division is that we want to boil this down to its core elements. Rather than writing every single bit of this down, we would like to just focus on the basics. So for synthetic division, we need to just write down these important pieces. First of all, we'll just copy inside this L the coefficients of the thing we're dividing by. 1, 4, -5, -14. We'll also copy the thing that we are dividing by, but this time, since it's x minus 2, we're just going to copy the 2. The reason for this is that we're copying the solution. The factor leads to a 0, so we're going to copy what the 0 would be. For synthetic division, you're going to repeat this process. You bring down the first number. Then you'll repeat for the rest of the time, multiply this number by this number, and bring it up here. Then add. We'll repeat the process. Multiply this number by this number, and add to get 7. We'll repeat one more time. And add to get 0. The last one we can put inside a box as the remainder. The rest of them are the coefficients of the final answer. X squared plus 6x plus 7. You'll notice a lot of familiar parts here as in the last one. The 2, the 12, and the 14 are the middle pieces that showed up here, here, and here when I was doing my division. This method is only possible if the thing you're dividing by is a linear factor, x minus 2, for example. It would not work if you were trying to divide by something more complicated, say by x squared plus 7. It will only work when you're dividing by a linear factor. If you are trying to divide by something more complicated, be sure to use regular polynomial division. It will still work. Now, the polynomial division theorem says that when I do polynomial division, I'm going to obtain something of this form. P of x is equal to d of x, q of x, plus r of x. Very fancy way of saying that if I want to take p of x and divide by d of x, my answer will be q of x plus a remainder. And the remainder will be r of x is going to be the remainder piece. Saying that it's plus the remainder is not quite correct. So we'll say q of x remainder r. The only thing that this theorem says other than this is that the degree of the remainder is going to be smaller than the degree of what we divided by. So if I divide by a second degree polynomial, then I could have a linear remainder or a constant remainder or no remainder at all. The remainder theorem takes this further and says that if I were to take a polynomial and divide by a certain factor, the remainder will be what I get when I plugged that root in. Let's do a real quick example to show this off. Let's say that I were to take x squared plus 5x plus 6 and divide by x minus 2. So here x minus 2 goes into the first piece, x times, giving me x squared minus 2x. Change to addition, 7x plus 6. This goes in 7 times. So that means that I will need to do 7x minus 14 and gives me 20. So the answer is x plus 7, remainder 20. Now, notice that if I have x minus 2 equal to 0, that would be x is equal to 2. If I plug in 2 here, 2 squared plus 5 times 2 plus 6, 4 plus 10 plus 6 is 20. In other words, the remainder that you get when you perform polynomial division is equal to the number that you get if you were to plug in the root of that factor directly into the polynomial. This is especially helpful because if you are able to plug in a number and get out 0, you know that it will divide evenly because there will be no remainder. This is summarized in the factor theorem. The number c is a 0 of p if and only if x minus c is a factor of the polynomial p. We can use this fact to more easily identify factors and then divide them out using polynomial division. With this in mind, we can actually factor polynomials of larger degrees as long as we are able to make a guess at least one of the factors. We already saw the intermediate value theorem last time. It will end up proving useful as well in the next section. So we'll come back to this bit. Let's take a look at an example here. I've got a polynomial, 2x cubed minus 5x plus 3. It says find p of 1 and use this to factor p. So what we're going to do first is find p of 1 as it suggests. P of 1, we simply get 2 times 1 cubed minus 5 times 1 plus 3. 2 minus 5 plus 3 is equal to 0. Because I got at 0, I know that x minus 1 is going to be a factor. So I can plug this in. X minus 1 divided into 2x cubed minus 5x plus 3. Let's actually do this the synthetic division way, just to get more practice at that. So we'll do 1, and then I need a 2, a 5, and a 3. 1, again, because this would be the solution that I plugged in, but 1. We'll bring down 2, then we'll multiply the 1 over and add to get 7. Then we'll do this again with the 7 and get 10. Oh, whoops. We need to be careful here because I've skipped a step. The step that I've skipped is that look at my polynomial again. What I'm missing here is a 0x squared. So this will need to be included in the synthetic division. So 0, negative 5, and 3. Let's repeat the process again. Bring down the 2. Then we will multiply the 1, giving us a 2. Multiply this here, giving us negative 3. And finally, zero. Now, we were expecting a remainder of 0. We knew this was going to happen based on the factor theorem. We just plugged in 1 and we got out 0, so there should have been no remainder. That's good. It means we did this correctly. 2x squared plus 2x minus 3. Let's see if we can factor this any further. In order to factor this, I'll make a chart here because I need to have two numbers that multiply to make negative 6 and add to make 2. The negative 6 comes from the 2 times the negative 3. If you know the box method or the cross method or some other method of factoring, you're welcome to continue to use your way. I'm going to set this up here. So let's see. Things that I could do to make negative 6. I could do negative 1 and 6 or negative 2 and 3. That gives me either negative 5 or negative 1. It doesn't look like this is going to factor. So instead, let's use the quadratic formula to find the other two roots. I will have x is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 2 times negative 3 all over 2 times 2. Negative 2 plus or minus 4. 4 times 3 is 12, 24 over 4. So that means that I will obtain x is equal to negative 1/2 plus or minus root 28 over 4. And from here, we can list out the three factors. X minus 1 is the first factor. X minus negative 1/2 plus root 28 over 4. And then x plus, or excuse me, x minus negative 1/2 minus root 28 over 4. We'll just include each of these two roots as its own factor. And there we go. In the next section, we'll look at ways to identify which roots we're possibly looking for. That's all we have for this one. Have a great day.